Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Geometric congruents are when we're looking at two shapes or more figures, but they have the same size and shape. Think about like the map of the United States. In your classroom that you might have had, you might see a picture up on the wall that has a map of the globe or a map of the United States, and we see how big it is. But then you might have that same map on your textbook or on your phone, and it's the same shape and shape, but it's not the same size. They're smaller. That's not what we're talking about when we're talking about congruence. We're talking about the front wheel on your car is congruent to the back wheel on your car, or the front left and the front right. They have the same size and same shape. They're both circles, and hopefully they're the same size, because otherwise you're going to wear one. And it's a type of, technically you could use rigid motion to be able to map one onto the other, like a congruence transformation. So like a slide, a reflect, a flip, whatever. But the big thing is when we're talking about congruent, we are going to use an equal sign with this, because we're not saying they're the same shape. We're saying they have the same size and shape. Okay, so you might see a triangle. Let me draw two triangles here. And I'm going to rough sketch, so hopefully I sketch them well. Okay, we're going to call this one A, B, C, and this one triangle D, E, F. Okay, from looking, we can see that this is approximately the same size as that. This is the same size as that. And I'm using, so notice how I did one mark the first time, and that would be angle C is congruent to angle D. They're not the exact same thing, but they have the same size and shape. Angle B is congruent to angle E. And then angle F is congruent to angle A. Don't ask me why I wrote that one backwards. I just did. I'm not sure. Still a true statement. So side AC. So we started at the 3 marks and we went to the 1 pink mark. So we need to go, since I went A to C, I have to go F to D. So the order matters. So this would be congruent to that. Notice how I put a 1 mark on it. Okay, so now let's go between the pink and the orange. So pink was C, orange was B. Here pink was D, orange was E. Those are congruent statements. And our last one. So I'm going to go orange to green. B to A is congruent to E to F. So when we're doing these, if you need to, I often call it a transparency. Get a transparency, use it, cover up your book, things like that, so that you can see this. So if I went triangle A, B, C, that would be congruent to triangle. Now see how I went from green to orange to pink? I have to go from green to orange to pink. I don't care whether they're in alphabetical order. One's alphabetical order, the other one spells the word fed. Okay? It doesn't really matter to me whether it's alphabetical order or whatever. What matters to me is that A corresponds to F, B corresponds to E, and C corresponds to D, which we stated right here by color coding. So being able to understand this relationship And where they match up is going to be key to proving triangles congruent, which is a massive part of a lot of geometry. And so all this color coding is not just being done random, it's being done for a purpose. Okay? So here we have a bunch of shapes. We have 3 triangles. And it says identify the congruent triangles using rigid transformations. That's how we're going to justify it. So what I have here is I'm at home, so I don't have all the things that I would maybe in my classroom. And my kids' photos have come in these plastic things. It's usually their team photo. And I don't have my dry erase stuff, so I actually just have a eyeliner thing that I don't like anymore. So anyways, so I'm just going to trace a shape. Assuming this doesn't break off every 5 seconds. By the way, it will erase right off. That's the beauty of this. Okay. So it looks kind of like this has been reflected over a line, right? So kind of reflect it. It would have been there, but then it looks like they slid it down. And absolutely that's lining right back up, especially if you look at where it was supposed to be. So it looks like ABC and JKL are congruent, but does this other one have the same? Oh, whoa, no. Like, this was supposed to be meeting like right up here, not, yeah. So it's close, but it's not quite there because this right here is going to be shorter than F to G. Okay. And it does look like we have that line of reflection. And we notice this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So could you go through and could you go back to some of the other videos and things like that to pick up the exact reflection? Absolutely. And by the way, assuming I have this on the correct point, yeah, there we go. It's going to erase right off. So you can reuse it as many times as you need to. So I actually like Crayolas better, but eyeliner does work in a pinch. So if we look at the line x equals -4, actually I'm going to bring this down first so that it's the same height. So I'm going to just bring everything down 3 spaces. 1, 2, 3, 1, 2, 3. And then 1, 2, 3. There's 3 spots in between them, right? So what's halfway in between? There we go. There's our line of reflection. So that's our rigid transformations. We would need to be shifted, translated 0, -3, and then a composition with a reflection over the line x equals, we're looking at 1, 2, 3, 4.5. So we're able to justify it. Now, we have to match them up correctly. Okay. Triangle ABC would be congruent to triangle, since I started with A, that reflected to J, B reflected to K, C reflected to L. So that order is going to be very, very important. And again, the other one was not going to be congruent because FG was not the same length as BC. So that right there kind of messed us up. So anytime you have congruent triangles or any other shape, you have to be able to do a rigid transformation to get from one to the other.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.